When most people look up at the moon, they think they know what they're seeing. Just a big grey rock floating up there doing nothing. But here's the truth, we've barely scratched the surface, and I mean that literally. For all our romantic poems and flag-planting missions, we've only explored a tiny fraction of what the moon really is. And for the longest time, the best data we had came from a few dusty rocks picked up more than 50 years ago. But that's changing fast, and not from who you'd expect. While everyone's been focused on Mars rovers, billionaires launching convertibles into orbit, and rockets that land upright like magic tricks, China has been quietly doing the real work. Not flashy live streams, not just animations and announcements. They've been landing real hardware on the moon, on parts of it we've never even seen up close, and bringing back pieces that no one on Earth has ever held before. And what they've found? It's changing everything. New types of rocks, strange minerals that don't exist anywhere else, actual water molecules where there shouldn't be any, and something else. Something that's got scientists rethinking how the moon even formed. Not to sound dramatic, but these missions are uncovering a version of the moon that's completely different from the one we thought we knew. And this isn't just about space trivia. Some of the stuff they've brought back might play a role in solving one of the biggest problems humanity faces today: energy. And maybe even where we go next as a species. So, if you've been ignoring the moon, thinking it's just Earth's boring roommate that never does much, you might want to look again, especially now that someone else is already up there, poking around. And they're not just collecting rocks, they're planning something bigger. For years, space exploration has been framed like a two-man race. The US and the Soviet Union, rockets, astronauts, Cold War flags on dusty plains, and to be fair, that story was epic. But while the West got caught up in nostalgia and budget cuts, someone else picked up the baton, quietly, methodically. Not with a loud bang, but with a quiet landing, and then another, and then another. That someone was China. You've probably heard about the Chang'e missions, maybe in passing. A rover here, a lander there. But what you might not realize is that while most countries have barely touched the moon since the 1970s, China has turned the moon into a long-term science project, and they're years ahead of the curve. Let's back up a little. It started with Chang'e 1 in 2007, which orbited the moon and mapped its surface and studied its composition. It provided high-resolution imagery and data on lunar soil distribution, setting the stage for future missions. Then came Chang'e 2, which refined the data. These were the warm-ups, clean, precise, and calculated. Not rushed, no race, just laying groundwork. It wasn't until Chang'e 3 in 2013 that China really made a statement. A soft landing on the near side of the moon and the deployment of the U-21 rover. It was their first robotic explorer on the lunar surface, and it worked. No PR stunts, no countdowns with dramatic music, just science moving quietly through grey dust. But what came next really flipped the script. In 2019, China became the first nation in history to land a spacecraft on the far side of the moon. This is something no one else had pulled off. Not because it's impossible, but because it's hard. The far side never faces Earth, which means you can't send signals directly. You need a satellite parked in space just to bounce commands and data back and forth. So China launched a relay satellite called Queqiao months in advance, positioned it beyond the moon, and used it to control Chang'e 4 and its rover, U-22, as they touched down in the von Karman crater, a place we've only ever seen from above. No landers, no rovers, no footprints. Until then, that mission wasn't about headlines, it was about geology. Deep, raw, untouched geology. The kind that hides in places light barely touches. The kind that can tell us not just how the moon evolved, but how we did. And they weren't done. Chang'e 5, launched in 2020, was the first mission in over 40 years to bring back samples from the moon. But unlike the Apollo missions, which relied on humans, Chang'e 5 did it all robotically. It landed, drilled, scooped, sealed, launched, docked, and returned, all without a single human on board. That's not just engineering, that's future-proofing. Then, in 2024, Chang'e 6 upped the game again. It landed on the far side of the moon and brought back the first ever physical samples from that hemisphere. Until that point, everything we knew about the far side was from looking, satellite images, remote sensors, guesses. But now, for the first time, scientists were holding that hidden half in their hands. And what they found wasn't just more dust. Here's something strange most people never think about. We've only ever seen one face of the moon. The other side, the far side, never turns toward us. It's locked in place, always out of view. And for a long time, that made it feel like it didn't really matter. All our landings, all our samples, all our science, it came from the same half, over and over again. Then China landed on the far side, and everything started to shift. The von Karman crater, where the Chang'e 4 mission touched down, isn't just some random crater. It sits deep inside the South Pole Aitken Basin, one of the largest impact zones in the entire solar system. This isn't just big, it's ancient. We're talking nearly 4 billion years old. When the asteroid that created it slammed into the moon, it didn't just dent the surface, it dug deep enough to punch through the crust and expose what lies beneath. And that's where things get interesting. See, most of what we know about the moon's structure is based on indirect clues, like measuring how sound waves travel through it, or guessing based on its surface composition. But Chang'e 4's rover U-22 actually found material believed to come from the moon's mantle, the rocky middle layer between its crust and its core. That's never happened before, not with Apollo, not with any robotic missions. These were rocks that had been buried for billions of years, finally exposed by a combination of a cosmic impact and smart robotic exploration. The rocks weren't just from deeper down, they were different. The chemistry didn't match the surface material we were familiar with. And that was the first sign that this part of the moon might be telling a completely different story. But then came the real surprise. Some of the volcanic rock on the far side was younger than expected. This didn't fit what scientists had predicted. The general idea was that the far side cooled quickly and stayed geologically quiet, cold, inactive, and old. But some of the samples showed signs of volcanic activity much later than we thought, as recent as 2.8 billion years ago. Now compare that to the Apollo samples from the near side, which were mostly older than 3 billion years. You'd expect the far side to be even older, right? But that's not what we're seeing. And then came Chang'e 5, which landed on the near side, but in a more geologically active region, and brought back rock samples that were even younger, around 2 billion years. This changed the entire timeline. Instead of seeing the moon as something that cooled off quickly and just sat there, we're now realizing it may have stayed hot and molten far longer than we imagined. Long enough to still be bubbling beneath the surface billions of years after it formed. That challenges one of the core assumptions of the giant impact theory, that a smaller body like the moon, having less mass and no atmosphere, should have cooled and gone dormant early on, but it didn't, at least not in the way we thought. On top of that, the surface characteristics of the far side are nothing like what we're used to seeing. The near side, the one we see from Earth, is full of dark plains called maria, formed by ancient volcanic lava flows. These flat regions made it easy for Apollo missions to land. But the far side, it's rough, jagged, brighter, and heavily cratered. The lava there didn't spread the same way, and the material has a totally different feel to it, clumpier, thicker, and lighter in color. These aren't cosmetic differences, they're geological fingerprints. They tell us that the two sides of the moon evolved differently, under different conditions, for different reasons. Maybe it's because Earth's heat played a role on the side that faced us. Maybe it's something else entirely. But either way, it means we can't treat the moon as one uniform object anymore. It's more like two distinct worlds sharing a single body. And for the first time, we're getting a glimpse of the side we've always ignored. What's emerging from these missions isn't just a better picture of the moon. It's a realization that we were working with half the truth. because models based solely on near-side Apollo samples are incomplete, as they represent only one hemisphere. Now we've got the other half, and it's revealing more than anyone expected. When the Chang'e 5 mission returned to Earth in late 2020, it brought back something the world hadn't seen in over 4 decades: fresh lunar soil. But this wasn't just about nostalgia or bragging rights. These samples came from a place no one had explored before, a relatively young volcanic region on the moon's near side, known as the Chang'e Dome. And what they found there, it changed the game completely. Let's start with the most surprising discovery: a brand new mineral. Hidden inside the lunar dust was a microscopic crystal that had never been seen on Earth or in any of the previous Apollo samples. China's researchers named it Chang'e, after the Chinese moon goddess Chang'e. Now, this mineral might not look like much. It's clear, tiny, and smaller than the width of a human hair. But it's what's inside that matters. Because tucked within this crystal is something scientists have been dreaming about for years: helium-3. If you've never heard of helium-3, here's why it matters. It's an incredibly rare form of helium that doesn't really exist on Earth. Our atmosphere and magnetic field shield us from it, which is great for staying alive, but not so great for collecting this stuff. The moon, on the other hand, has no magnetic field and no atmosphere, which means it's been soaking up helium-3 from solar wind for billions of years. And it turns out, Chang'e is basically a natural storage container for it. Why do we care? Because helium-3 is considered one of the most promising fuels for nuclear fusion, the holy grail of energy. Unlike our current nuclear power methods, which rely on splitting atoms and produce radioactive waste, fusion fuses atoms together, like the sun does. And helium-3 fusion, in particular, could generate massive amounts of energy without the dangerous radiation or long-lasting waste. Now, to be clear, we don't have a working helium-3 fusion reactor yet. But if, or when, that technology becomes real, the moon isn't just a dusty rock anymore. It's a battery, a floating reservoir of clean energy that could power Earth for generations. And China? They've already found the first trace of it. That's not speculation, that's data. But the discoveries didn't stop with helium-3. The same mission also made a discovery that caught a lot of scientists off guard: water. And not in the usual places either. Up until recently, most of the water on the moon was believed to exist only in permanently shadowed craters at the poles, places where sunlight never reaches. But Chang'e 5 found actual water molecules. How? It came from a new mineral called ULM1, a type of hydrated salt. The water wasn't sitting there like frost or ice. It was locked inside the crystal structure of the mineral itself. This is a huge deal because it means water might be way more common across the moon than we thought. It's not just hiding in cold, dark corners. It might be mixed into the very surface materials all over the place. And that changes everything. Because if future astronauts don't have to haul water from Earth and can extract it from the soil itself, then lunar bases become way more practical. Water means drinking, growing food, and most importantly, making fuel. Hydrogen and oxygen are rocket propellants. If you can split water on the moon, you can refuel there. That's the difference between a one-way trip and a sustainable outpost. So, to recap, China found a new mineral, a rare fusion fuel, and confirmed that usable water might be everywhere, not just at the poles. And they did it with robots, landing in places nobody had ever touched before, and bringing it all the way back for study. By now, it's pretty clear China isn't just exploring the moon for curiosity's sake. They're collecting samples, yes, but the way they're doing it, their choice of landing sites, their focus on long-term resource potential, the pacing of their missions, it all points to something else. They're planning to stay. Most countries treat the moon like a photo op. Go there, plant a flag, maybe take a few selfies, and head home. But China, they're taking notes. They're mapping terrain. They're testing how to drill, how to return materials, how to communicate from the far side, how to analyze water in volcanic soil. All of it looks like rehearsal for something permanent. They're already talking about building a lunar base. Not someday, not in the distant future, but by the 2030s. It's called the International Lunar Research Station, and it's being developed with partners like Russia and several other countries. But make no mistake, China's leading the charge. They're not imagining this base as just a shelter either. It's designed to be fully robotic at first. Autonomous systems doing construction, managing equipment, collecting data before humans arrive. That means the groundwork will already be in place before the first astronaut sets foot there. Imagine walking into a station on the moon where the lights are already on and the robots have been waiting for you. Now think about what that means in the big picture. If you control the first permanent station on the moon, you're not just doing science, you're shaping what comes next. You get first access to materials. You set the tone for collaboration. You define the rules of engagement. That includes how resources like helium-3 or lunar water are extracted and used. If those things become the fuel of the future, whoever controls the supply controls the future. And again, China's not doing this recklessly. Every Chang'e mission is part of a clear sequence. Chang'e 1 and 2 mapped the moon. Chang'e 3 proved they could land. Chang'e 4 went to the far side. Chang'e 5 brought back samples. Chang'e 6 went even further. Now, Chang'e 7 is set to launch soon, targeting the moon's south pole, where many believe the largest reserves of water ice exist. That mission will include a lander, a rover, a mini-hopper, and even a drone to scout terrain. Yes, a drone, flying on the moon. After that, Chang'e 8. That one's big. It's supposed to test in situ resource utilization, basically using the moon's own materials to build things. Bricks from lunar soil, oxygen from lunar rocks. Real infrastructure, made on the moon, using what's already there. You see the pattern. It's not random, it's a blueprint. Meanwhile, what's everyone else doing? NASA's Artemis program is trying to catch up. It has bold goals, but constant delays. Private companies are promising a lot, but still stuck in the launch and relaunch stage. There's ambition everywhere, but execution, right now, China's the one quietly getting it done. And that's what makes this moment different from the space race of the past. Back then, it was about speed. Who could get there first? Now, it's about who knows how to stay, who knows what to bring back, and who knows what to do with it. And if we're being honest, China has been checking off every one of those boxes while the rest of the world is still debating what the moon is even good for. And the answer is becoming clearer every day. Energy, water, construction material, testing ground, and maybe one day a launch pad for Mars. But before we get ahead of ourselves, let's come back to the core question. What does all this mean for the moon? And for us? Because these discoveries don't just rewrite our understanding of the moon. They change the way we look at our future. When you step back and look at everything, the rocks, the water, the helium-3, the layered history written into volcanic soil, it's hard not to wonder if we misunderstood the moon from the very beginning. Maybe it wasn't just a passive lump of rock orbiting Earth. Maybe it was more like a time capsule, one that's been sitting there quietly, holding on to clues about the early solar system, waiting for someone to finally start asking the right questions. And now, someone is. China's space program didn't just stumble onto a few new facts. They systematically rewrote huge parts of what we thought we knew. And they didn't do it by recycling old methods. They pushed into places no one had dared to go. And they came back with samples no one had ever touched. That alone is rare. But what's even rarer is what they found in those samples. A mineral we've never seen before, holding helium-3, a fuel that could one day change everything about how we generate energy. Actual water molecules locked inside rocks, not in polar shadows, but right out in the open. And volcanic materials that throw our moon formation theories into question. If you connect the dots, a pattern starts to form. This isn't about checking off scientific boxes, it's about understanding how the moon works, what it's made of, how its layers evolved, and what that tells us about our own planet. Because Earth and Moon are not strangers, they're linked, possibly even born from the same catastrophic event. And if that's true, then understanding the moon is one step closer to understanding how Earth itself became what it is. But here's the catch. Whoever understands it first, whoever builds on it, lives on it, extracts from it, that's the one who sets the pace for what comes next. China seems to understand that. They're not rushing. They're not broadcasting every move. But bit by bit, they're building an advantage that could define the future of space exploration, and maybe even life beyond Earth. And the rest of us? We're watching, still thinking of the moon as something we visited once and then forgot about. But the moon hasn't forgotten us. It's still there, still full of secrets, still offering answers we haven't asked yet. We used to look up at it just to admire the glow. Now we're starting to look again, but this time to figure out how far we can really go.